Hi students, and welcome to this experiment 8 SN1 and SN2 reactions.
So we're going to be performing the experiment and taking the video recording, but you are the one who's going to be making observations and processing the data. So be sure you're writing everything down, you're taking good observations if there's a color change or a precipitate formed or anything else that you notice. You're going to process the data, you're going to interpret and analyze, and then you're going to be the one writing up the lab report based on what you've seen us do in the lab.
That's right. So the lab report will be constructed in much the same way you have previously, except the one thing is you're going to basically make up one file and you're going to upload it to the e-learning lab site. All right, so in there, experiment 8, we'll have a little site where you can actually upload one file. And so we want you to upload that PDF file of your lab report. We'll give you some more details at the end of this video about how to construct your lab report. But just know we want you to do one file and upload it there. And you should not email the experiments to us without 56 students in the lab. So getting 56 emails could be a challenge. So we want to definitely do everything through the e-learning site. There are two mechanisms that we're going to talk about in this laboratory, and they're the same ones we've been talking about in lecturing. We'll see in the lecture videos. One of them is SN1, substitution, nucleophilic, meaning molecular. The particular reaction that we're going to look at in this experiment is this one. We're going to take some substrate, right? It has a halide on it, that's written by X. This would be your chlorine, bromine, iodine, etc. And it's going to react with silver nitrate in a solution of ethanol. Right? When that reaction occurs, our substrate is going to be now attached to the alcohol with its oxygen in the middle, and that's an ether group. We're going to get a solid precipitation that forms. Right? This is going to be the silver chloride, silver bromide, silver iodine, whatever happens to be there. And then we'll also generate a little bit of strong acid. Right? So this is the overall reaction. And what we'll be able to observe and what you'll want to make note of in this experiment is the precipitation form. That is the solid that forms. So that's the overall reaction. Let's think about the mechanism. Remember the mechanism behind it. And typically what happens is that we'll just leave this as a carbon with some other groups. Actually, probably should put R groups in there that are going to form. I think about that as R1, 2, and R3. This guy reacts. All right, and so because this is a tertiary group, and that's the importance of having the 3 R groups, is that the mechanism is that this halogen group can eventually break away. And this is really the first step, forming a carbocation. So a carbocation is a group, a carbon group that has a positive charge. As this goes away, then this halogen, it just goes away as in X minus. All right, so in this case. But then we can get a nucleophile to come in and attack this. In this case, the nucleophile is going to be the ethanol oxygen that's here. I'm just going to make it a U, NU, for nucleophile and negative charge. And it's going to come in and react here. And you end up with a new covalent bond that forms here. This. R1. And so we end up with a new compound. So again, what would happen is that ultimately in this one, because the X is going away, it would interact with the silver to form precipitation, and that's just a visual cue. Again, that's a silver salt, and then we would get this as our organic product. Right, so this is SN1. One thing about it to remember is that this solvent here is ethanol. It also happens to be the reactants, but this is important for SN1 reactants. Remembering that the ethanol is what we call a polar protic solvent. So it's polarized in the sense that it has this oxygen group, which makes it polarized. All right? Besides that, and so something can have just an oxygen and make it polar. But this one's polar, and then it's protic because it has an H attached to an oxygen. And so basically anything that is a hydrogen bonding group would be a protic. That it has this proton, it's attached to an oxygen or a nitrogen, are the 2 most common ones. All right, so that's important. SN1s are favored when we have polar protic solvents because it helps to stabilize this carbocation charge. All right, so this is the first mechanism that we're going to look at, and this is an SN1 mechanism, and so we're going to have conditions, this guy and this one, which will make this an SN1 favoring reaction conditions. The second mechanism that we're going to look at is SN2, mechanism which we are going to do in this experiment and has SN2 favoring conditions. All right, so remember, it's substitution, nucleophilic, bimolecular. All right, so there's two things that are involved in the rate limiting step. So this particular reaction, we're going to have some substrate, R, and it has a halogen group, and this is the the bromine group, and it's going to react with sodium iodide in this particular case. And it's going to react, and the iodine actually is going to serve as the nucleophile to react. And we're going to form this new R group with an iodine. The other halogen, X here, is going to go away, and then it's going to actually form a precipitation with sodium. So we're going to get sodium chloride, sodium bromide, and again, it's going to give a precipitation. This is, again, going to be our visual cue. This will be the solid cloudiness that forms, and this will give us an indication of the reactions there. And again, that's going to be like sodium chloride, sodium bromide. Organic chemistry, we're more interested in this guy, since it has the carbon group, but this is our visual cue. Now again, let's remember the mechanism for SN2 and what this looks like. Again, the R group is typically some compound carbon that has halogen attached to it, and I'll just indicate it as this. And again, it's oftentimes this carbon is primary, or is probably the best one, a methyl group, meaning that there might be more H's here, and then possibly an R group here to make this one's more reactive. The nucleophile, you might remember, comes in and it can attack here this carbon. Because of this difference in charge, this one's a little bit positively charged. This one comes in, and then there's a second arrow, and that goes away. Remember, we typically draw this with a transition state, and it's important oftentimes to show this. I mean, all reactions have a transition state. But it's important to show this because this one's so well understood. So we often put a little diagram there. And so then we would have H here, and it gets flattened out. So we would have an R group here, and a hydrogen there. Right? And so these lines, I'm showing them as full bonds right now, but really are probably more like half breaking, half forming bonds that would form, hence the transition state. Then what happens is that the nucleophile forms a new bond with carbon. We get the inversion of configuration that we've seen before. And then also we get the X that's out here in solution. Of course, then that X would actually form, in this case with sodium, because there's some sodium, and actually form the solvent. But in terms of this mechanism, this works. All right, and so again, we have a nucleophile. This is considered the substrate. This X group is the leading group, and it's the same type of leading group we saw in SM1. So it's a halogen that goes away. And again, remembering that there are certain leading groups that are better, and in terms of the larger, like iodine, bromine tend to be better than chlorine. And so you have to think about that in this mechanism. But it moves through this one step. It's a one-step mechanism, but two arrows, and the nucleophile and the substrate are both important for the speed of this particular reaction. All right, so this is the SN2 mechanism, and we're going to set up conditions that are SN2 favoring. All right, so one that they have this, but then one of the other conditions that make this SN2 favoring is the solvent. And the solvent that we use in this one, which we haven't talked about in this video until now, is acetone. All right, so this is acetone. It has a carbon double bonded oxygen, which makes this polar, right? So it's a little bit polarized. But this one's aprotic. Why is it aprotic? Because it does not have a hydrogen that's attached to an oxygen or a nitrogen. It does have hydrogens that are attached to these carbons, and so because of that, they cannot form hydrogen bonds. And so this one's considered polar aprotic. All right, and so this type of solvent, aprotic ones, are really good for SN2 reactions. All right, whereas the protic ones with the hydrogen are really good for SM1. All right, so we want something like acetone or some other solvent where there's no hydrogen attached to that oxygen. All right, so this is the SN2 mechanism, and so we're going to proceed to do the experiment where we look at some reactions under SN1 favoring conditions, and then the same sort of reagents under SN2 favoring conditions, and see how that works out. In the textbook, it gives you sort of very good rules about how which types of molecules, whether they're primary or secondary, tertiary, react under SM1 or SN2 conditions. We're going to find out that once we go in the laboratory that still roughly holds, but there's a little bit of gray area, so to speak, in between. Or some that should only react under SN2, they actually do react ISM1 favoring conditions. All right, so take your time, watch us do the video, and make sure you're recording the data. All right, students, we're going to perform the experiment now as is indicated in the procedure. So just a couple of things about our setup. For our timer, we have an iPad here. We're going to start the timer once the reactions start. We have our reagent here, and this is the silver nitrate. It's in ethanol, as we talked about that solvent. We have test tubes for the seven reagents, and then the reagents are here. So before that happens, I want to demonstrate what's going to happen when we start to add these, and so you can see what it would look like. So let's follow one for just a demonstration. So this is a test tube, and this is just one of the compounds. And again, the first thing is we put in 3 drops, and so we'll put in the 3 drops. 2, 3. And then again, it's always good. One of the reasons we haven't used the parafilm is because these are volatile, so they become gases, so we're going to make sure we keep them all there. And then we're going to use 1 milliliter of reagent. So I've got a 10 milliliter graduated cylinder back here, fill it up with reagent, and we'll pull out about 1 ml of the reagent. And then as I pull off the parafilm, when we mix in the reagent, we'll start the timer, so go, and then put the parafilm back on to make sure you're not evaporating, and to shake it up. What will happen is the precipitate that we talked about will start to form. You can start to see that it's a white precipitate, as we would expect. And again, this one reacted fairly quickly and was fairly intense, so probably within just a few seconds it was finished. And so from the data, you would want to know where the start time is and also where the end time is. And luckily with the video lab, you can actually just start and stop the timer, start the timer by stopping the video feed. So now we'll go ahead and do the rest of the 7 reagents. So again, we'll start by adding 3 drops to each of the test tubes. All right, so first we'll do number 1 here, and so I'll add 3 drops to 1, 2, 3. Return this, and also make sure, as the directions say, that we want to put the parafilm on. As we add the other ones, these will be open to the atmosphere, so we don't want them to evaporate. So that's number 1. That's 2. Here's 3. We'll get a little more than 3 drops. Next we need a parafilm. So again, remembering that we have a mixture of primary, secondary, and tertiary halogens, and then some of them are bromine, some are chlorine. So again, approximately 3 drops to each one of those. Okay, so they're all covered to keep any evaporation down. And next what we're going to do is we're going to add a milliliter of the reagent, the silver nitrate, to them. And when we press the timer for the first one, once we add the reagent for the first one, we'll press the timer, and then about every 30 seconds I'll add in the next one. All right, so this one we got time 0, this one will start at 30 seconds, and then 60 seconds, and so forth. And your goal is really to make sure you get the time difference when it forms the white precipitate that we've talked about before. All right, so we'll go ahead and get the parafilm off of number 1. And I have a graduated cylinder of some of the reagent, so I'll pull up in the middle of that. And once I add this first one, we'll time it, and then we'll start the timer. So ready, set, go. So add that one together. And again, making sure that we mix it up and keeping our parafilm on top of it. So we'll set that one down. And again, notice that they don't all necessarily react right away. Some of them might take a couple of minutes, some of them 10 minutes, some of them might never react in terms of at least under these conditions. All right, so add the next guy. So this is number 2. Adding a little bit of it, mixing it up. So set that one down. So notice now we have some that might react. So add this one in. Make sure we get nice and mixed up. So we're going to get number 4 ready. Do this with one hand. Continue to notice some of the reagents being added, and notice that one is fairly quick. The last one. So we'll leave the last two uncovered since they have clearly already reacted. But what we'll continue to do is to observe them. Right? So those two reacted clearly, and then notice what's happening with the rest of these. And again, your goal is to measure them until a time until you think there is noticeable precipitation, or turbidity as we called it previously, right, where you can actually start to get some cloudiness, some milkiness in the particular reaction. Right, that's what we're going to call a precipitate. It doesn't have to be completely cloudy like one of these, but just cloudy enough. Right, so again, making sure that you're watching the timer. Again, the good thing you can do, since you're watching on videos, you can pause and actually get the time that's displayed here on the iPad, and you can think about when it was the start and stop time. So we're going to give these a little bit more time to react. Remember, we go up until about 5 minutes, and then we want to start putting some of those that have not reacted into a warm water bath. And again, remembering that water bath is really the delta, the little delta symbol that we put above a reaction arrow. and that's to help get it further reactive. All right, so we'll pull out a couple of these in just a second, and if they haven't reacted, and we'll see if we can get them to react a little bit more. So I think we can all agree that 7 and 6 and really 5 have reacted. Of the first 4, it appears to me that number 2 definitely has some appreciable precipitation, but 1, 3, and 4, they can still use some water. All right, so we're going to pull these out, these 3, and we're going to put them into a 50-degree water bath, and we're going to check them there in every couple of minutes. All right, and then we'll come back and show you what those look like. Alright, so you can see the timer, so we'll pull these out. So we have 1, put these in order here, 3 and 4. And so you can see that they're starting to form. So I would say 3 certainly probably has a little bit of precipitate that just occurred. I think 4 is likely there as well, getting just a little bit. And you can make an observation about how thick and the precipitation is. And what about number 1? Maybe not so much. So maybe we'll stick that one back in just for a little bit more and see if it would come out. So again, so think about the time that we've put in there, and so again, noticing that this one went in right after 5 minutes. These were just a little bit early in terms of the water bath, and so you can think about that in your conclusion. We'll put this number 1 back in for a few more minutes. Alright, so you can see it's about 10 minutes, and here's number 1. And it probably has a little bit of white, a light white precipitation that's forming there. So, and perhaps you can see that a little bit on the screen, but we're going to go and say that that one's finally reacted. All right, so again, thinking about the amount of time that it took, the first full 5 minutes in the air, and then at least 5 more minutes in the water bath. And again, compare that to some of the others. So some of them, like these guys, reacted right away, or almost instantaneously, and then some of these, it took time in the air, and then a couple of them we actually put in the bath just a little bit early for that. All right, so but remembering, these are reagents. They're under SM1 favoring conditions. And that's what we say SM1 favoring. Not everything reacts and acts exactly the same as you might expect in terms of should this one even react at all in SM1 favoring conditions. But you can see that it did react, but not necessarily at the same intensity or the same concentration in terms of the amount of product as the rest of the. So this is SM1 favoring conditions. Now we're going to work with the SN2 favoring conditions. So again, we use a slightly different reagent. Remember, this is 15% sodium iodide, and it's in acetone. We'll have the same setup with the iPad timer and the test tubes, and so I'm going to get right to work adding the 3 drops of each of the 7 reagents to the test tubes. Make sure we put our parafilm there, keep them from evaporating since we're just a small number of drops. So now we have all of our drops that have been added. And so again, I have 10 milliliters of the reagent that is here. And so we want to start by adding 1 ml to each of the test tubes. And again, on the first one, we're going to start our timer, and we'll sort of time that up to have it mixed, and then the other ones will be about every 30 seconds. So the first one ready, go. And so again, we'll mix this guy in. Put that back. Two. Alright, so looks like we have one that's already gone. And we're working on the other ones. Remember, what we need to see is a solid that forms. A color change, this one maybe a slight yellow. That does not indicate a reaction. We're actually looking for something that's solid, precipitation. Okay. So we're going to let these continue to react. See if we get some more white that forms. Okay, so we're at about 5 minutes, at least for the first one. And again, noticing it has a bit of yellow tint to it. That's not a precipitate, so we're actually going to put that one into the water bath. Okay, number 3 might need a little bit of assistance, so we're going to toss it into the water bath. All right, number 4, same thing. Okay, 5, let's see on the back. And 6 as well. Bring number 1 back in, and number 1 has just a little bit of cloudiness to it. All right, so I think it's just coming around to be informed, so we're going to put that one down. Number 7. Alright, so you'll notice number 5 has now reacted. We're still waiting on the other ones though. Looks like number 7 as well. Number 7 has reacted. So we'll just check the other ones just to be sure. Yep, so we're still waiting on the other 3. Okay, with number 3, we're about just about the full time water and bath, and so you can see that very little, if anything, has formed there for number 3. All right, so pull number 4 out, and again, not much happening on number 4. Maybe just, yeah, that's still pretty clear. So I think these have gone the full time, both in just air temperature and then also the water bath, with nothing really happening. All right, so we have 1 more left, and that's number 6. And so we'll give that just a little bit more time and check in. All right, so number 6, finally done, and again, like the other ones, you can see that the 3 and 4, that is, the other 2 in the water bath, there was also, it also did not react. So as you're thinking about this, you might consider a couple of things as you're sort of reviewing this, analyzing the data. So number 1, thinking about the leaving group. Was it a bromo group? Was it a chloride group that actually was leaving? Also think about the structure of the substrate. Was it primary, secondary, or tertiary? Some of the post-lab calculations, questions, interpretation really lead you through that. But consider that and think about what might be common among the things that reacted and what reacted the best. All right, so this brings to inclusion then the SN2 favoring conditions where we had sodium iodide as our reactant. Now that the experiment is completed, it's time for you, the student, to actually write a report. This report will be much the same that we've done this semester already, but it'll be slightly different based on the online nature of this. All right, so let's take a look at that. First of all, we're going to have you submit 1 PDF file. You're going to convert all your information to a single PDF file. You're going to upload it to the lab e-learning site. So there in coursework, you'll find experiment 8, and you'll be able to upload a file, and you're going to upload 1 PDF file. How you write the report, we're going to give you 2 options. Number 1, we're going to have you type everything. So the purpose, procedure, data, conclusions, the whole thing, much like you would type up a report for actually English or something like that, that type of report. So everything's going to be digital. And you convert that to a PDF and upload it. Or you can do more of what we've done already, which is where you handwrite the purpose and the data in your lab notebook, and then type a conclusion. And then we want you to bring those 2 together. You can actually just take pictures of your handwritten notes from your laboratory notebook and put that together with TurboScan or GeniusScan or a Notes app, something along those lines, and get it into 1 PDF file and upload. So in the end, the experimental report will be submitted by you, the student. The instructors will grade it as is typical, but remember the difference is it's now going to be uploaded through our e-learning site as single PDF file. We thank you, students, for being patient and working our way through this. We know these are challenging times, and this is really a difficult situation for many people. But if you are patient and you work through this, we're going to finish this class this semester, and then you'll be able to move on to other chemistry classes or other classes in your discipline.